How you doing today? Sorry to put you on the slow going here. I'm doing better, but still not great. I did do my at-home COVID test yesterday, and it's negative. So I'll do it again today, and hoping it's still negative. So we'll see. It's been uh, been a little crazy, but the travel was good at least. It's just getting sick near the end of it was rough. So uh, it's bad if I'm drinking tea and hopped up on cold meds instead of drinking my usual coffee. So we'll be a little slower today than usual. Sorry about that. I didn't want to miss too much. So we're not too far behind actually, which is pretty good. So um, had Project 3 we pushed out till next week, and I'm actually going to push that out till Wednesday as well because I had some folks who wanted to meet and I haven't been able to make it to campus. So let's go and update that one first. So let's push that one out to Wednesday for Project 3. I got this one here. So we'll make that, here we go, the 16th, in case anyone wants to chat on Monday about that one. We'll push that one out. Okay, so we got that one updated. And then we're going to talk about stacks and queues today. And then we'll talk about the group project on the 14th as well. Not want to be there for a few folks who can do questions live and that sort of thing. And that should be okay because we'll still get basically a whole month for it. And with Project 3 not being due, I don't actually think very many people were going to get started on it ahead of time anyway. So if that sounds okay to you folks, we'll just talk about stacks and queues today. And we can go from there. Does that sound like a plan? All right. I do need. I'll grab my stylus here. That's what I was missing. I haven't even unpacked everything from the bags. There it is. I have my pen. Took that with me in case I needed it. All right. And then, make sure this is plugged in. I don't think it's plugged in. We're getting there, folks. How are you guys doing today? Is everyone else doing all right? Let's see, where's my USB port? There's one. Got my handy dock over here on my desk. Stella. My cat's missed me a lot. Come on, Stella. Come on. All right, so stacks and queues. The specialty data structures here. Let me make a new project here that we can use for specific behavior. And we're actually going to take advantage of our linked list for this one. So we're going to look at some performance for this. This is stacks and queues here. Yeah, it was a lot of fun. Kids had a good time. It was a little crazy, but it's good. We brought some extra friends to help wrangle all the kids because it's a little crazy. Oh yeah, we'll update on close. There we go. So we had our, let's see, let's add a new header here. Let's grab our linked list here from GitHub. I think this is easiest to copy here. So this was our circular doubly linked list, was our best version of this one here. I've got Pragma once, twice in here. I guess it's Pragma twice. That's fine. All right. This is our circular doubly linked list. There. Okay, so that's how that happened. And I'm even going to leave a note in here because we copied this, and that's a good habit, right? Say, hey, we got it from here. Now, there's actually, for what it's worth, this code can change. So if you want, you can get here, you want the permalink here. So copy permalink. Not much different, but you get instead of it being based off of the main here, it's based off of, hey, this is the specific commit. And this is just a big commit hash. It's ugly, but it's okay. So it'll always be that version of it here in GitHub, rather than, right, this URL, if we go and change the linked list class later, is going to be the latest version. So I don't really care one way or the other, and it's probably not going to change anytime that quickly, but it should be okay. All right, so I think our linked lists were okay. They worked out well for us. We got this one cleaned up. Now, the idea with a stack and a queue here, and we'll just make this a main file here, is it's a very particular type of data structure. And we'll use our namespace. My voice coming out okay? It sounds real raspy to me, but as long as you can hear me okay. Much better than Monday when I was just had no voice from all the hacking. Oh, I'm sorry. I posted on Canvas, but it was like 9 something. I was hoping we'd all be feeling better this morning, and by the time my wife got up and I got up, and it's like, no, this is a no-go. All right. So the idea with a stack and a queue, again, they're very specialty types. So we've looked at some performance of different data structures, right? And we said, hey, the array list, or I'm sorry, our vector or array-based storage here that's resizable is nice, and on average it performs really nice, but we do have those worst cases where it does need to do the resizing, and that's unfortunate because that takes additional time. And again, it's only in the worst case, and it averages out okay, but we know it is going to perform slow. So if we're adding lots of things, we're going to hit that resizing a lot of times. So the linked list was great because we could just add to it, and it was always fast, no matter what. Best case, average case, worst case, because there was no resizing that had to happen in terms of n. That's that big O notation. Okay, let me pull up a little document here. I think we can draw on it. Oops. No, Stella, you can't be writing on my pad. Sorry, she wants to play. She missed having it run home. So we said this O notation, right, was O of what? So O of 1 was like a constant time. That's our best performance here. Why is it doing some weird highlighting? There we go. So this is best, right? And then it got worse as you went O of log n, O of n squared, O of 2 to the n, and O of n factorial, right? Sort of working your way through. It's not anything you need to have memorized right now, don't worry, but like log of n was better than O of n, which was better than O of n squared, which is better than O of, or no, is hang on, get that right notation here. O of 2 to the n, and which was better than O of n factorial, right? And this is worst. Right, so in terms of performance, in terms of how many n items we have in the collection. Stella, drive me crazy, baby. There's no door to the basement, unfortunately. It's like keep them out. Oh my goodness, there's the other cats. Hey. So when we wanted to take our vector, so again we have average is generally what we care about. There's also best, which almost no one cares about, and then worst is important to know. So really we don't care about best time, but average time is very important here because on average we're going to get most of the time here. And then worst is good to know because bad things could happen if we always hit our worst performance. So for our vector, right, on average for adding, it was still constant, this O of n, because the resizing gets amortized across here. So add, right? Or this was what pushback, I think is what you wanted to call that one, right? For a pushback function. That was fine. To find something, right, to see if it contains, took O of n. We had to go through all n items, and that's okay. With our linked list here, this add to front or add to back, add front, really just add anywhere, was going to be constant except for add at an index. That one was going to be slow. Finding was still O of n, adding at an index, and this is also adding at an index to the vector, because we had to get to a certain index and then shift everything down. So the shifting was slow. With the linked list, getting to the spot is slow here. Now, when we talk about a stack and a queue, so we're finally getting to the new stuff here. So when we talk about a stack, we've used stacks before without really realizing it with the recursion. Right? That's that idea of the call stack. We said, hey, here's the function, here's main at line 12, and then here's some function at line 27, and here's that function at 25, and they just get stacked up, right? And when this one's done, it comes off the stack, and we go back to the next one. When this one's done, it comes off the stack, we go back to this one. And we kind of saw that we were debugging in our recursive project. So the stack, the idea here is that it is a first in, last out, or FILO, some people say. First in, last out. So when you put something new on, it's on top. So the operations we have, you can push, you can pop, and you can peek. So pushing adds to the stack, popping takes off from the stack, and peeking looks at the top item of the stack here. And all of these then, if we're going to use a vector, would possibly have the slow performance, right? When we're adding something, removing should be fine, but adding might be slow in the worst case. So if we use a linked list, adding is always fast. So using a linked list behind the scenes for this works out really well. And that's what we're going to try and do. So we're going to add a new class here for a stack. Let's get our class for stack, and then it's of type T here. Let me grab our notation for that. Type name T. Okay, and we're going to have a private section and a public section, and we're going to include our circular doubly linked list. So when a stack is of type T, it'll have a circular doubly linked list. Oh my goodness, what did I call mine? Doubly linked list. That's right. Doubly linked list of T. So this will be the list. And then when you make a stack, right, for our constructor, we'll say we've got our list then, right? Really, we don't actually have to do a whole lot here. That should take care of itself, just being the list. But then we're going to have our functions. We're going to have a push that doesn't need to return anything. So a void function here for push. A T item is going to take our list, and we're going to add to the back then the item. If you want to get the T item and pop here, we'll take that item off. We're going to return my list dot remove back. Right? Remove the item from the back. We add to the back, we remove from the back, and then it's going to peek here. We're going to return list dot. We had a at here, right? Our at list dot size, or do we not have a size? Oh my goodness. Because we were tracking that, right? The number of items? I guess we never added a size, did we? We should probably do that, right? Should probably do that. Okay. Let's see. Does our at function work well for this? Yeah, that was a to-do. We left it here. That's okay. Okay, let's cheat. Let's cheat here. We'll because we know that's going to be slow. Let's forget that. So let's add to the front here and remove from the front, and then we'll get list at 0. That'll be the first thing. So if we're always adding to the front of our linked list here, right? We always have a new front, a new front, have a new front, have a new front. We can get them back off here. So if I want to add a couple things to my stack, right? Let's add some numbers here. So if we add, say, a 2 here, and then we add a new value, add a 4, it's over here. We add an 8, it's over here, and we add a 16, it's over here, right? So we're always getting at the front value of our linked list here. You can imagine like a stack, right? 2, 4, 8, 16 stacked on top of each other. It's just a linked list, right? Each one points to the next one in here as we go. So I think adding to from will be easy. That way we don't have to, because we didn't optimize for getting the last item. So I think that works out well for our code. And that's it. That's all it does. Now, you might be wondering, like, well, what good is a stack? And, it's not particularly useful because we could just use a linked list and just do these operations. But what it lets us do is if we have a problem that is modeled well with a stack, it makes sure that the only way you interact with it is the stack way with push, pop, and peek. So if we're going to expose something to someone who's using our code, so it's not necessarily great for like things internally because we could just manage it ourselves, but if we're going to give external access through like public functions here to someone who wants to interact with our class, we can force them to only interact with it as a stack. So they essentially have a limited version of those public functions than they would if we just used a regular doubly linked list here. So we're limiting their access to only doing the things that we want them to do here to interact with it as a stack, because that's all we want them to do. Right? When we're working on our code and debugging and things and the way calls get stacked up, right? You can't go from the 10th function call in the stack down to the 5th, right? You have to work them in order. So it being a stack makes sense because you're only getting access to it that way. So it just kind of depends on what problems we're solving here. So we'll have a silly little lab that will be using a stack and we'll be using a queue because it fits well for particular problems. And that's all. Right, so that's the stack. It's not bad with the linked list here. And the queue is similar. Now, if you are British, you'll understand what a queue is. If you're American here, then we don't usually use the word queue, but it's a line, right? So a queue here is a first in, first out data structure. So the first value in is the first one out. So 2, 4, 8, 16 or so, right? You're always going to work the front of the queue. And when that front is gone, then you have a new front of the queue, right? We were very familiar with queues at Disney World, right? They're lines. You get in the line, and that's how it goes. Now, don't get me started with their fast pass or lightning lane or whatever other nonsense, but that's okay. If you want to pay to skip through the line, then sure. We can't model that behavior very well with our regular queue. That's okay. We're doing a nice fair queue where everyone who gets in line just gets in the regular line. You don't get to skip ahead because you paid more money. I'm not salty at all. It's okay. So that's the queue, right? You're always going to work from the front. So with a queue, you can enqueue an item, which puts it at the back. You can dequeue an item, which takes it from the front, or you can just have access to the front, right? Peek, essentially, you're peeking at the front. So our queue works out relatively well. So I'm going to actually just copy all of that here for stack because it's pretty similar. And we'll add a new header for queue. This is our class queue. It's again of type T. We have a linked list, so you can enqueue an item. So when we're adding to our list, we're going to add to the back here. When you want to dequeue an item, we're going to remove from the front. And when you want to check the front, we're going to give you the front value. That's all it is. Now we probably want something in here that gives us like sizes. We should probably do that, right? So we should have an int for size, returns this number of items. There we go. And then we can add in size for stack and queue as well, because it's nice to know list.get or list.size, right? There we go. We'll just return the list size. That way you know whether or not you have any values in here. And then another common one as well is an isEmpty. I don't think we have that one here. Is it empty? So check for empty that we were doing. No, we don't have an isEmpty. So we could add that one in. So isEmpty is a nice little Boolean function that just says the return list.size equals 0. If the size is 0, we're empty. It's true. We'll return true. If it's not 0, we're going to return false. We're not empty. These are just kind of nice to have. Just for people who want to interact with it. You can loop while it's not empty and do something here. because we need some way of knowing if we have items in it, because we don't have access to all the other ones. Excuse me. I think I got the mute button there. All right. Awesome. So that's our stack and that's our queue. So let's go use them, right? So if we want to include our stack and include our queue here, make a stack of whatever, make a queue of whatever. So let's just do them of type integer, because that's nice and easy and basic here. I guess we could do like a names for a queue. I don't know, it doesn't really matter here. So we'll make a stack here of we want int here. This is be my numbers here, and then we'll make a queue of string here. Let's include string, lowercase string, right? String. There we go. This is name. So I have a stack of numbers and a queue of names. So names we can enqueue. We'll add in like Eric gets in line, and then names.enqueue. Queue, and Jeb gets in line, names.enqueue, and then Vivi gets in line. So we got a line for a ride, right? That's fine. And then let's add some numbers to our stack. So we'll add numbers. We'll push. Say we'll do like the powers of 2 because that's fun. Numbers.push 4, numbers.push 8, and that's probably enough for now. So we'll have three numbers and 3 names. And we can just loop through. We can say, while my numbers is empty, and we want like not is empty, right? Well, it's not empty. We can see out. Oh, I did IO stream, right? Yep. Numbers dot pop. Get the value out and pop it off. So because this is a stack, we should get the last thing on first. We should get 8, 4, and 2, right? And then we can have a loop. We'll say while my names.is empty, well, it's not empty, and we can see out names.dequeue, and then line. So we should get them in order. We should get Eric, Jeb, and Vivi, because you get them in the order which you put them in. First in, first out. Give that a shot real quick. Oh goodness, build errors. Missing type specifier. What did I do wrong here? Circular. Oh, I didn't rename it here. That's what. So, was that wrong in my other code that I stole? Goodness. Wow. Did we never run the circular doubly linked list? Hang on, I'm confused now. Do we have them both in here? Circular doubly linked list. Did we not finish? I really don't remember what happened because it's been so long ago now. So that's a bummer. Okay. So sure, that's okay. So we want our starts next is gonna be the first thing. Right, it's always the first one. That's at index 0. Okay. Starts next over here. Sure. Okay. It's first. It's first. It's first. Starts next. Friends, I really thought we ran that code. That's unfortunate here. Okay. And it's no longer a doubly linked list. It's a circular doubly linked list because we changed the name of it. Oh goodness. We'll get there, friends. We will get there. Okay. Maybe that's enough. Hey, there we go. Oh, it crashes. Oh. What are we even doing here? Main line 18, enqueuing, queue. Start is null. Did we break it? I think we broke it. Circular doubly linked list. Start is a new node. Points to itself. We broke it. Did we really not run this? I'm so confused now, friends. Okay, let's try it. Let's try it here. Let's put a breakpoint in. Before we even got there? Alright, Stella. Oh, Daisy. Other cat. Let's see. Why is that breaking? Oh, wait, numbers is working? Okay, let's see. Alright, so numbers works. There's just the queue of names that doesn't work? That's interesting. My queue of type string is failing. Type name T. Didn't we copy this from stack? Oh, because we didn't give it a string. We gave it constant characters. That's obnoxious. Okay. Yeah, it's not treating it as a string. Okay, so string name is Eric. How about that? Now can I add name? See if that works for us. Okay. Nope. So it's just when we're creating it here. Q of type T. Huh. Maybe we can't have null there. Why doesn't it like type string? You know what? That's okay. It's okay. We'll just add some ints here. More numbers. We'll just cheat here because it's not working right now, and that's okay. We'll add 2, 4, and 8 again. That ought to work, right? All right. Let's just see if we can get them out. Oh, goodness. Nope. Moving node. All right, we broke it. Popping off our front here. Okay. Remove front. Remove node. Starts next. That should be the front. Start. Start doesn't have a next. Why doesn't start have a next? All right. Well, it is rather broken. I think it's the doubly linked list problem, though, not this problem here. Let's try it and see. So let's go add in our numbers here. So step into our code. We're going to add to the front of our list here. Add into the front. We have this is our doubly linked list. We have our start node, which is a dummy node. Its next and previous point to itself. Looking good so far. So add between should add between the next and the start because we want to add to the front. So the next and the previous, let's see. Node next, node previous. So we have the next and the previous are the start here. It's looking good so far. So we're going to make a new node with the data, the next value, and the previous value. So then our new node has the data of 2, has the next and the previous here. Looking good so far. Oh, we never fixed up. That's what it is here. We have the new node here. We never fixed the other one. So my new nodes previous next is the new node, and the new node's next previous is the new node. This is what we get for not testing our linked list code here. That is unfortunate. I'm going to have to go update that in the other repository, aren't I? Yeah, we'll have to do that. Hi, Stella. Right, so when we add the new node, we've put ourselves in between, but we didn't tell the nodes around us that we are now part of it as well. Yeah, so we did for that one. Huh. Let's try it again. So we're going to add some values here. Let's see, so then our numbers has the list here. It has a start. Start has a next. Next is 8. Good. 8's next is 4. 4's next is 2. 2's next is the dummy start node again. Right, we got the nice little circle of df0. Is it not? df0. There we go. It's kind of hard to see those addresses. Sorry. Okay. So maybe that'll work then. Let's see if it'll pop off. All right, it's not crashing. Not crashing. That's a good sign. All right, and here's our output window. So in the stack, 842, and then the queue, 248. Probably should add some better output here. Out stack, and this is our queue. All right. See if that just runs now. Oh, we don't need the debugger. Continue. Does that look a little nicer? So we see the values in the stack, values in the queue. All right. Awesome. Sorry about that. And I need to get some more tea soon. All right. So we can stack things, we can queue things, put them all in, get them back out. Works out pretty nice for us here. Figure out why that string thing wasn't working later. So what do we fixed up circular doubly linked list here. Let's go fix that one in the other code as well. All right, so let's open up my other project then. Bin project. That's not what I wanted. Documents, GitHub, 200. Where'd it go? Linked lists. There we go. We'll go fix that one up over here. Okay, and then we can go commit that in GitHub, and life will be good. 200. So let's do just the linked list first. So we had to fix the class name, fix the betweens. So this is where it's nice to see, like, this is what code changed here with these commits, right? The green and the red. So we added new code. We removed that, really changed that line. Here's what was different between them here. Was nice. So here's fixed circular doubly linked list. Doubly linked list. I think that was better. All right, and then we got stacks and queues. Some examples. Stacks and queues here. Do that. All right, awesome. I wonder if it was broken in doubly linked. Did we try any of these? I feel like we tried some of these. Yeah, okay, so we did doubly link this. We never did the circular one. That's what it was. I think we ran out of time. We were having fun. Stella, baby. All right. All right, I can close that one down. And close my whole Visual Studio. All right, now it wants to update. Sure. Well, that's fun. I did tell it I wanted to update before. All right, so stack and queues, they're fun for very limited use, very specialized. Hey, I only want to give you access to do these things and interact with them in certain ways. Works out pretty nice. So I think that's actually just about good today. For our lab today, we're going to practice stacks and queues with Mr. Dia. We'll solve problems using stacks and queues just to get familiar with using them here. And then next week, we'll get into searching and sorting. We'll talk about the group project. We'll talk about project 3, that did get pushed out to the 16th, in case you missed that. And then we can finish that up. No class during Thanksgiving break. Come back, talk about streams, file streams, and then a little talk about ethics from notes here. And then in December, we just have group project work time for you folks to get together and work on the project. And then in our final exam slot, instead of a final exam, you'll present your final project that we'll talk about next week. That sound like a plan? All right, awesome. So I will let Visual Studio finish updating here. Oops, I have to, yes, that's fine. Retry. Yeah, I don't, what standard collector service? I think it's just confused. That's okay. I'll take care of that after. So folks will have lab tonight with Mr. Dia, and we'll go from there, okay? Thanks everybody for flexibility. Sorry it's not been the greatest week, but hopefully you're doing well, and I'll see you around. Thanks everybody.